Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're continuing along with Eloquent JavaScript, Chapter 6, The Secret Life of Objects. Today we're going to be talking about inheritance, another principle of object-oriented programming. If you guys remember last time, we talked about getters, setters, and statics, and how you can use the get and set methods within classes in JS to set instance variables or fields, or get instance variables or fields, and then do some customized logic within those get and set methods, and how that can be used as a powerful way to display data, or to only encapsulate data and only show data that you only want the user to see. Today we're going to talk about inheritance, kind of a concept that we use a lot in Java, using the extends keyword. So you can have parent classes, or you can have child classes rather, inherit from parent classes. And we're going to see that today. Let's just jump right into it. If I can go to the first slide. There we go. Let me just make sure. There we go. What if you need to make a new class, but you needed flavors of another class? So let's say you have a class of a car, right? But you wanted to make a new class that contains flavors of car, but it's not exactly a car. Or let's call it a vehicle instead. So you want to make another class that it is a vehicle, but it needs its own flavors. Like you want to make a truck class, right? So what's a truck going to have? A truck's going to have a bed. A truck's going to have maybe a Hemi in it. Like the type of engine might be different. So you need all the attributes that a vehicle has. You need the wheels, you need the doors, you need the dashboard, but you need other flavors. Like I mentioned, you need a bed, you need the Hemi, you need towing capacity, etc. So you can derive properties from an old class while adding properties for the new class, and you can do this via inheritance. Basically, inheritance is where a new class inherits from an old class. You have a parent-child or a main and a subclass relationship. So how can this be achieved? Well, in JavaScript is a prototype-based language, and objects serve as prototypes for other objects. So everything in JS goes back to a prototype, whereas like in Java, everything inherits from the object class. So in JavaScript, there's something called prototype chaining, or I don't know if that's exactly what it's called, but that's kind of what I'm calling it. But you do traverse up this prototype chain whenever you try to find properties of an object that you've created. And if it's not found on that object, it goes to that object's prototype. So it works back up backwards through the prototype chain until it comes across the property. So if you have a truck class and you want to get like the wheel size, you didn't explicitly define that in the truck class maybe, but you did define it in the vehicle class. So if you try to call it on your truck object, it's not going to find it. It's going to go back to the vehicle. It's going to go up the chain back to the vehicle superclass to get that property. So it's going to go from child to parent. And that's what's called prototype chaining. I don't know if I just made that up, or that's what I'm going to call it, though, prototype chaining. Next. So there's different ways to achieve inheritance, and this kind of stems from different ways to create objects in JavaScript. Classes are a weird thing in JavaScript. I don't really use classes in JS. I more so do like the first two ways, and even like the second way that I have there, I don't really do that. I feel like I just create objects using the bracket notation, but I don't really have them tied to a class. So this is kind of weird for me. I don't really use JS like this, but you definitely can use OOP in JS. So the ways to create objects, you can use Object.create. It's a static method. We learned about statics last time. You can use constructor functions, and you can use classes as of ES6. So taking a look at Object.create, this is where you can see on the right, I started an example with the help of ChatGPT. You have a parent object prototype, which is your prototype. This is like your main, this is going to be like your main class. You have an animal object with the bracket notation, and it's going to have a property of make sound, which is a function. So every time you call animal prototype dot make sound, it's going to print off generic animal sound. But then you can use that animal prototype to create a subtype of animal prototype. And you use this via Object.create, and that's what's done on the bottom there, where you have a child object. Now you have a bird, because a bird is of a type animal. So now you create a bird object using Object.create, using the animal prototype as a template, as the blueprint for creating that object. So now you can add your own attributes to the bird prototype. You can say bird prototype.fly, and you can assign that a function where you print the bird is flying. So you use the dot notation to assign attributes. This is kind of like you're using setters, like in a class. You don't say dot set fly, you just say dot fly, something like that. So next slide, you can see now, let me go back and let me distinguish one thing. So here you're creating a bird prototype, right? You're creating, essentially, think of this animal prototype and bird prototype as your classes, right? This is going to be the blueprints. So you're creating a blueprint of animal. Now in the next slide, you're creating your object, and you're creating a new bird object. So I wanted to just distinguish that there, that the syntax here, it's like I'm creating Object.create is, yes, it's used to create objects, but you're also creating a prototype using Object.create. So think of the bird prototype and the animal prototype as classes, if that's a little bit more clear. And then on this slide, you are seeing that you create a new bird object using the bird prototype. So now you have access to all the bird prototypes properties as well as the animal types properties. So when you call mybird.name, you're assigning it, again, a property of a name, which is a sparrow. So now when you print out mybird.name, it's going to print sparrow. And then check this out. When you print mybird, or not, hang on one second, guys. I might have to sneeze. Okay, nope. I think it went away. False alarm. But when you call mybird.fly, it's going to print the bird is flying. Why is that? Because mybird, you created mybird from the bird prototype. Now look back here, you assigned a function to the fly property where it prints the bird is flying. But now when you say mybird.makeSound, it's going to print out the generic animal sound. And you're saying, Chris, how does it do that? Well, because you created mybird from the bird prototype, and you created the bird prototype from the animal prototype. So it's going to have the same properties as animal. It's inheriting everything from its parent class. So when you call mybird.makeSound, this is where it goes up the prototype chain, because it's going to look at the bird prototype. Oh, does the bird prototype have a make sound attribute or property? No. Does the animal prototype that it inherits from have the make sound property? Yes. So that's how it's able to print generic animal sound. And then here, yeah, you can even add functions to the bird prototype. I mean, that is kind of what I did. Bird prototype.fly, bird prototype.make sound. Well, you can override the functions or the properties of animal prototypes. So that's kind of what I did in that other screenshot. You have a make sound on the animal prototype, but you now can override it or create your own make sound on the bird prototype. So that's Object.create. That's showing some inheritance there. What about constructor functions? Here, we are actually going to be using the prototype keyword. And in a way, this kind of looks similar to Object.create, but really the only difference is, maybe not the only difference, but a big difference is the use of this prototype keyword. So you create a function that looks like a class name, but it is in fact a function because you're using the function keyword here, and you're assigning fields within the function. So this is a constructor. This is a constructor. This is just like you have constructors in class syntax or in Java. This is a way to do that. This is a way to create objects and do inheritance in JS by using constructor functions. Hopefully I'm not being repetitive there. But once you have a function, once you have your blueprint function here, then you can add methods, properties, etc. to the prototype of the animal constructor. So this is where you actually use a prototype. So you take the function name dot prototype dot your attribute. So we're going to have a make sound attribute on the animal prototype. And again, this is going to be a function, generic animal sound. Now you're going to have a child constructor function inheriting from animal. This is the same thing we did in the previous example with, we use Object.create to create a prototype, create an object using the animal blueprint. And then from there, we can create our own bird using the bird blueprint. So we have a function bird now that's going to take in certain attributes specific to a bird. And then when you want to create or when you want to tie this bird to animal and inherit from it, you've got to use this syntax of animal.call to call the parent constructor with the current object as the context. You pass in this, which this is an interesting keyword in JavaScript, and that deserves a whole entire video on itself. But this passes in the context of the method here, or the function of bird. And then you're going to pass in the name. Why? Because animal needs a name in order to instantiate this constructor. It needs the name. And name is being passed into bird, and then it's going to be passed into animal. So now bird is going to contain the same attributes as animal, along with additional properties. And you can assign additional properties within this bird function, like a wingspan. And that's what you're passing in here. So a little bit different. You're seeing some different terminology here. The prototype keyword, a call function, static function I might add too. So let's see how this is used. So bird.prototype, this is now like a similar thing that we did over here where we assign a make sound to the animal prototype. We're now going to assign an inheritance chain to the bird prototype. And then you add more methods or more functions or properties to the bird prototype. So here, this was interesting. You're still using Object.create here. So you just created a function called bird, constructor function. Now you assign the animal prototype to the bird prototype. So you set up an inheritance chain. So now you can do the same thing that you did to animal, where you assign a function to the make sound property of the animal prototype. And here you're going to assign a function to the fly prototype of the bird constructor function. Now you can create an object using the new keyword. So I guess another big difference here, instead of using Object.create here, you're going to say new bird. And you're going to pass in the name. You're going to pass in the wingspan. And now you can access the properties, name, wingspan. You call mybird dot notation right there. You have access to this output of generic animal sound. You have access to that because of this setup of the inheritance chain here. So you're going to have access to the properties of the animal prototype, as well as this newly created property of fly, which you created on the bird prototype. So it looks similar, but a little bit different of a feel with the constructor functions on setting up an inheritance. Now, lastly, you can use the class keyword, which is a more modern way to do it, again, as of ES6, relatively recent. So this is where you actually use the class keyword, and then you have a constructor of the class where you pass in arguments that will instantiate objects of this class. So we have an animal, same example that we used in the first two instances, guys, where we have an animal, we're passing in a name to instantiate the animal, and then the animal's got a method here, method of the class called makeSound. Now, when you want to set up an inheritance chain here, you create a new class that extends animal, and this is where the extends keyword comes in. And pretty clean way to I'm most used to doing it this way because of my experience in Java. This is how I would do it. This is like the most clean way to do it for me, because I know exactly what I'm doing. I know exactly by this line that I'm extending animal, and then I'm setting up an inheritance. Bird is a child of animal. And then again, in bird, you have your same constructor function using the constructor keyword. It's going to take in a name and a wingspan. You have this super call. So this is kind of similar to the constructor functions, the previous example, where we're saying animal.call. Here, we're using the super keyword to call the constructor of the parent class, which is animal. And you're passing in name because animal takes in a name. And then the additional properties specific to bird, like the wingspan, right? This all is entailed in creating a bird object, because since a bird extends animal, you need to call the superclass. You need to set up animal and bird, essentially, in this constructor because of that inheritance relationship. Going down, you have your own customized method in the child class of fly. That's going to print out the bird is flying. And then in the next slide, I have the creation of a new bird object, and then you access the properties the same way that you've seen in the other last two examples, Object.create and the constructor functions. So ways to set up inheritance and create objects in JS. Now, inheritance, like I said in the first slide at the beginning of the video, it's a fundamental concept to OOP. It goes along with encapsulation and polymorphism. So ways in which to, encapsulations means like you hide the data within a class, you encapsulate it, you put it in a capsule, and then you only show the data that you want to show. Polymorphism, I think we talked about this in a video, where you method overload or override, so you can customize or inherit method. I don't want to say inherit, but you can reuse and retool methods from interfaces in in your code and make them do different things by overloading or overriding them. Overriding is where, oh gosh, you guys are testing me now. Overriding, so you override the toString method, and you can then make it return. You can make it return something different. Overloading is where you have a method with different arguments or different types of arguments. So that's ways to achieve polymorphism. But inheritance goes along. It's a fundamental concept to OOP, where encapsulation and polymorphism untangle code. Inheritance tangles code. So it makes a point in the book, Mergen makes a point that says you got to be careful with inheritance because it tightly couples your code. I think we talked about this in clean code as well too, where you got to think about if you make a change in an inheritance change, everything downstream connected to that inheritance has to change too. Like if I change the animal class, let's say animal now is going to take in a weight, right? Because all animals are going to weigh something. Some are going to weigh more than others, but they're going to weigh something. Then everything downstream of animal has to change too. So you tightly couple your code. And that's why they were saying in the book, you got to be careful with inheritance because it's going to potentially tangle up your code in a tangled up mess. So guys, that is inheritance in a nutshell. And I want to thank you guys for listening. Let me know if you have any questions. Hopefully my voice came across okay today. It's a little stuffy. But thank you guys so much for listening. Tune in next time. And I appreciate you guys so much. My name is Chris. This has been Chee-Tash. Take care, everybody.